Water is essential for survival. 71% of the Earth's surface is made of water. We can only access about 0.024% of this water, yet technically it is globally enough fresh water to meet everyone's wants and needs and demands. Yet it is not distributed evenly among the countries and causes many difficulties because of it. Lack of access to clean water causes many problems on different levels. It's a global health issue because the lack of safe water is the single leading cause of illness and results in people getting preventable diseases such as diarrhea and typhoid fever. It's an economic issue because poverty ensues and food production costs increase when farmers have to spend more money to irrigate water to their crops. A women's and children's issue because in most developing countries, they are the parties responsible for locating and retrieving fresh water for their families. Countries fight for water resources and the tension creates national and global issues. Of course, it's an environmental issue because the actions to acquire more fresh water result in depleting aquifers, collapsing water tables, lower river flows, shrinking lakes, declining fish and other aquatic species populations, and degradation of ecosystem services. The resolution to these issues would mean determining the best way to make water resources available to everyone without depleting them. The hydraulic cycle recycles and purifies water. Some fresh water is locked away in glaciers, which would take a long time to melt, so we can't really get anything from them. No worries though, we have other ways to access fresh water. Not all necessarily safe for the environment, but we do them anyway. Groundwater is our most important source of fresh water. Groundwater is when precipitation infiltrates the ground and percolates downward through spaces in soil, gravel, and rock until an impenetrable rock layer stops it. We also get water from aquifers, which are underground caverns and porous layers of sand, gravel, or bedrock through which groundwater flows. Now, groundwater usually goes underground, and to access groundwater, we have to drill to get through it. The groundwater and aquifers, mostly aquifers, also have to be recharged. So therefore, when they're recharged, they're replenished, and that is usually by reliable surface runoff, which is another source of water. However, surface runoff can be lost through seasonal floods and is not always available for human use. Shockingly, there is a such thing as a non-renewable aquifer. A non-renewable aquifer gets very little water, so it gets very little recharge. It's very deep underground, and it's usually made of tens of thousands of years to even make it into an aquifer. If we were to mine it, which we do, it would be mined from a non-renewable resource. Now, aquifers can also be a non-renewable resources, the ones that are naturally recharged. When we overdraw or over prompt from groundwater and aquifers, then they can naturally be replenished. We are therefore depleting that renewable source of water. And of course, that's not helpful to us because we're using up a resource, and the faster we deplete it, the less useful it becomes over time. There is a such thing as reliable surface runoff, which also helps to recharge aquifers and groundwater, but we can lose some of this in rivers and streams by seasonal floods and is not always available to human use. Globally, water withdrawal increased sevenfold, and 35%, we withdraw about 34% of the world's reliable runoff. So many areas are using the water resource unsustainably and therefore increasing our ecological footprint. Affluent, developed countries such as the U.S. use much more water than developing countries, and usually is used inefficiently. You know, the t-shirts you're probably wearing right now took about 25 bathtubs full of water to produce it, and that's only one. Think of how many people in your classroom are wearing a t-shirt right now. That's a lot of water being used inefficiently, where somewhere over in a developing country, there is conflict between, say, the Middle East over who gets to use this water and how much water is to be used for drinking and eating and cooking and bathing. When we extract groundwater, we run the risk of making water tables fall. In the US, aquifers supply almost all of the drinking water in rural areas, and 30% of it is irrigated. Now, water tables are falling due to overpumping of these aquifers because we deplete them faster than they can be naturally replenished. And it's also used to water grain crops. The largest grain producers are India, China, and the United States. And 500 million people are being fed by grain produced through unsustainable use of groundwater. Because when an aquifer is overpumped, the thing that a farmer does is that they drill a deeper well or use a larger pump and therefore use more energy to get the water to the surface. And again, the aquifer is still depleted, or it's too costly to pump the remaining water. Other effects of overpumping groundwater would be creating a land subsidence, which is when the sand and rock in aquifers collapse. Now, one example of a subsidy, which is a sinkhole, and it can appear suddenly and unexpectedly. The underground cavern collapses after being drained of the water that supports it, and sinkholes can swallow homes, businesses, roads, cars, and trees. Oh, so nice to suddenly drive by one of those. Dams are another way that we access water. A dam is a structure built across the river to control the river's water flow. After the river is dammed, the flow creates an artificial lake or a reservoir behind it. A few advantages of building dams is that it provides irrigation water above and below the dam, provides water for drinking, it's useful for recreation and fishing, can produce cheap electricity, and reduces downstream flooding. Now, small dams usually don't have that many environmental problems, which is why they can be used to store water, and dams are often used in the Middle East. However, larger dams can have bigger drawbacks. Some of the disadvantages of using a dam is that the flooded land can destroy forests and cropland and can displace a lot of people. Worldwide, building dams has displaced between 40 and 80 million people from their homes and flooded an area of mostly productive land. There are large losses of water through evaporation. It deprives downstream cropland and estuaries of nutrient-rich silt. The risk of failure and devastating downstream flooding and disrupts migration and spawning of some fish. Going to the fish aspect and how dams can harm or deplete fish species, 1/5 of the world's freshwater fish and plant species are either extinct or endangered, primarily because of dams and wildlife withdrawals have destroyed many free-flowing rivers.
The United States alone can do so much more to use water more sustainably. Now, the low cost of water for most Americans is so low that many see it as this sort of abundant resource, and while it may seem that way, we're really blowing away an opportunity to meet most of the world's water needs for the foreseeable future by wasting so much water. And the truth is, we all can make it possible to reduce water losses to 15%, which would succeed in meeting our water needs, most of them. This is economically possible. However, it's all up to the people genuinely caring about this to really make it happen.